Okay, so this is lesson 2.1.3's review and preview. And here it says solve each of the following equations without using the quadratic formula. You shouldn't need the quadratic formula on this, so at all. You can use it, but you're not going to use it. So, all right, let's go to this first one. So first off, all I'm going to do, it's already set equal to 0. These are all quadratics. I'm just going to factor. And so literally all I'm doing is taking y out of each term. That means that y here equals 6 and y here equals 0. Notice we have a 0 and a 6. Okay. This particular one on part B, you've got to subtract 7 from each side because you've got to set it equal to 0 since it's in quadratic form. So now that becomes n squared plus 5n equals 0. So similar to part A, you're going to factor out an n, and you're going to put n plus 5 equals 0. So then here we have n equals 0 and n equals -5. Because again, zero product property, we want to see what causes each of those to equal 0. Part C, we're going to subtract 3 from each side because again, we're trying to get it equal to 0. So C is going to now be 2t squared minus 14t equals 0. So now we're going to factor out a 2t. So I'm going to take out a 2t. That leaves behind t minus 7, which equals 0. So again, even though there's a coefficient on it, the only thing that can make it 0 is still 0. So it's going to be t equals 0 and t equals 7. Okay? Last one, we're going to add 4 this time because we're trying to set it equal to 0. 1/3 x squared plus 3x, okay, equals 0. So we factor out a 1/3 x. So what's left in there, and this is where it gets a little tricky sometimes, because remember, 1/3 times whatever goes in this parenthesis has to equal 3x. So it's going to be x plus 9. So 1/3 x times 9. So if I was to redistribute that, it would equal the 3x. So that's why it looks a little different than what you're used to. But again, just like every single other one, x equals 0 because that's the only thing that's going to make that equal 0, and x equals -9. The question on E is 0 is one of the solutions of each of the above equations. What do all of the above equations have in common that causes them to have 0 as a solution? Well, if you think about it, let's kind of circle all of these. So look at that, that, and think about this. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. All of these are missing the c term, okay? There is no constant on any of those, and that would change the zeros that you have. So all you have is the squared term and another number attached to a coefficient that's the same variable. So that is what it's missing. Every single one of them is missing the constant term. Okay, moving on. Okay, so this is 2-36. Find the vertex of each of the following parabolas by averaging the x-intercepts, then write each equation in graphing form. So the first thing we're going to do is we're going to go and get a pen, because we kind of need that. And I'm going to go ahead and say, well, my x equals 3 and my x equals 11. Those are the two zeros that I'm going to have because that's what make each set of parentheses equal 0. So then I'm going to go 3 plus 11 divided by 2 because there's two zeros. So that's 14 divided by 2, which equals 7. This is our x of the vertex. Okay. Then we're going to take and we're going to plug in the 7 into the equation. So y equals 7 minus 3 times 7 minus 11. So that is 4 times -4, which equals -16. And that is our y. So our vertex is 7, -16, and our equation is y equals, remember this is a horizontal shift to the right, but we do x minus 7 squared minus 16. So there's that equation, okay? Then we go to part B. So part B, we're going to find our zeros again. It's going to be x equals -2 and x equals 6. So we're going to add negative 2 plus 6 over 2, which is 4 over 2, which equals 2. That's our x, okay? So then I'm going to plug it into the equation. Y equals 2 plus 2, and then it's 2 minus 6. Interesting. This will be 4, again, times negative 4 means y equals negative 16. And that's our y of the coordinates. So our vertex is 2, negative 16. So our equation is y equals x minus 2 squared minus 16. Okay. Now, part C, we've got to do a little factoring first. So I'm going to bring back my diamond method up here. If I can do it without running into the problem. Remember, it's two numbers that multiply to 40 and add up to 14. And it's a negative 14, okay? So what two numbers multiply to 40 and add up to negative 40? Negative 14. Well, that would be a negative 10 and a negative 4. So negative 10 times negative 4 is a positive 40, but you add them together, it's a negative 14. So that means I've got to write, it's y equals x minus 10 times x minus 4. So x equals 10 and x equals 4. All right. So then we add them together. So 10 plus 4 over 2 equals 14 over 2, which equals 7. That's our x. Okay. It's our x. Ooh, let's make sure you know that's an x. All right. So we're going to plug it in. All right. Y. Then we plug in our 7. So it's 7 squared minus 14 times 7 plus 40. So that's going to be y equals 49 minus 98. And you're all going, oh my gosh, she's done all this in her head. No, I did on a separate piece of paper before I started recording. So this all equals, once you do 49 minus 98 and add it to 40, it equals negative 9. So our vertex is, let's write vertex is 7, comma, negative 9. So our equation is y, hope you're catching the pattern here, x minus 7 squared minus 9. Okay, now part D, it's a little annoying because it's already in vertex form. So I already can tell you what our vertex is. Our vertex is 2, negative 1. But they wanted us to average the zeros. So if I wrote that equation out farther, you're going to have it as x minus 2 times x minus 2 minus 1. So our zeros would be x equals 2 and x equals 2. Well, if you add 2 plus 2 and put it over 2, it's just going to be 2. So we already know that because we figured it out up here. And then when you plug it into the equation, which we're going to do in yellow, like we've done with all the rest, I'm going to plug that in, and it's going to be 2 minus 2 squared minus 1. Well, what does that equal? 0 squared minus 1. So y equals negative 1. So our vertex is 2, negative 1. Well, we write that in, which we've already done. Oh, we've got to box that just because that's the way I am. We got to write it out. Well, it's y equals x minus 2 squared minus 1, which is already what you have for D. So I think that's interesting. I don't know if you do, but I thought that was interesting. Okay, let's move to the next problem. Okay, so this is 2-37. It won't take quite as long, but it says here, did you need to average the x-intercepts to find the vertex in part D of the preceding problem? As we already discussed, no, we didn't. It was already in graphing form, so we didn't need to do it. The vertex was just 2, negative 1. And then how do these coordinates relate to the equation? Well, they were actually in the equation and they were in graphing form already. So I'm not exactly sure what more they're looking for an answer on this, but how do the coordinates relate to the equation? Well, the equation was y equals x minus 2 squared minus 1. Well, That represents the x of our vertex, and this represents the y of our vertex. So that's pretty much all you have for 2-37. Okay, so this is 2-38. Scientists can estimate the increase in carbon dioxide in the atmosphere by measuring increases in carbon emissions. In 1998, the annual carbon emission was about 8 gigatons. A gigaton is a billion metric tons. Over the last several years, annual carbon emission has been increasing by 1%. At this rate, how much carbon dioxide or how much carbon was predicted to be emitted in 2010? So this is an exponential growth equation. So we're going to use their C of x. That's what they want us to do an equation in. But we're going to just write it out as whatever our starting amount is. Okay, so I'm going to call it, let's just do n subscript 0. So that means my starting amount. Okay, and then it's going to be 1 plus our rate, okay, to the x. And in this case, x represents time in years. Okay, rate is our percentage in decimal. And we know it's an increase because it said it has been increasing by about 1%. So if I'm going to make this equation, we're going to start with B and then go back to A. We're going to go to B and we're going to come up with our C of x equation for this scenario. Whoops, sorry about that. That is not correct. All right, C of x equals, and our starting point, or n subscript 0, is 8 for 8 gigatons, okay? Then we have 1, because that represents 100%, plus the increase in decimal, so that'll be 0.01 for 1%. And then we raise it to the x, which in many equations you would see it as t because it represents time. So that is the equation for any year, okay? And then in particular for A, let's go back. It's going to be C, and we're going to put in, instead of x, we're going to put in 12 for the number of years. So it's going to be C of 12 equals 8 times 1 plus 0.01 to the 12. Now, when you type that into your calculator, you're going to end up with 9.015 gigatons in 2010. So that helps you because it's 1998 plus 12 is 2010. All right, that's how you would do it. And honestly, I would go after setting up the equation first and then plugging in the information for the scenario, because that way you have your rule and you can test any number of years that you want to test. So, and that's number 2-38. Moving on. Okay, so 2-39 is kind of interesting because you're probably sort of still learning this too, or trying to remember it. Make predictions about how many times the graph of each equation below will touch the x-axis. You may first want to rewrite some of the equations in a more useful form. Now, what you're going to see is we're going to talk about each one, and then I'm going to put a page I'm going to let you see a page of the graphs, and we'll talk about how they look and why we came up with the answers we came up with. Well, let's start with A. On A, I have two distinctly different zeros here. So I believe it's going to cross twice. So it's going to hit 2 times. Okay. I think because it's going to hit at 2 and 3. So that means it has to go down and come back up, or go up and come back down, but it'll hit 2 times. On B, we only have x plus 1 times x plus 1. So to me, it's only going to bounce. It's going to hit it once, but it's like a double hit. It's going to hit it 1 time, and I like to say it bounces. And you'll see what I mean once we look at the graph if you haven't already graphed it yourself. C, if we factor this, it's going to be x plus 3 times x plus 3. So again, it's going to bounce. So it's going to hit 1 time. So like I said, I like to say bounces because it's kind of like a double consonant in a word. Like funny. You know, it hits n and then it hits n again. That's kind of like what happens when you have two sets of parentheses or two binomials that are the same in a quadratic. All right, so hopefully you understood what I just said, but it made sense to me. Okay, on D, you factor that, it becomes x plus 5 times x plus 2. So to me, that's going to, again, it's going to hit at -5 and -2, but it has to go down and come back up or go up and come back down at some point. So I believe it's going to hit it at 2 times. Okay. All right. Then we have E. And E, if I factor it, is to x plus 2 times x plus 4. So that means it's going to hit -2 and -4. So I think it's going to hit the graph at 2 times also. All right. And last but not least is our F. Now, you could graph this, keep the negative in, but usually what I do with these is I take the negative out because I would rather deal with positives. I'm just a more positive person. Ha, ha, ha. So then I would factor x plus 2 times x plus 2. So that's telling me that this graph is also going to hit at -2 twice. So I believe at F, it's going to bounce. But let's just go ahead and do this the way we did it before. One time. And we're going to say bounces. Okay. All right. So the next one, it says check your predictions with the calculator. And we'll talk in a second about what that looks like because I want to go get that picture. So just 1 second. Okay. So here we go. So the other thing I want to say is when I think that these, when I say these bounce, this one, and this one, it also is our vertex. Okay. So we would also say it's the vertex for each. And if you look at these, remember I said on A it crosses at 2 points. Well, we have that. B, it bounces. See what I mean? It bounces, boom, it goes back up. So it's like a bounce, okay? So that's B. C, let me go ahead and erase. This is going to drive me nuts right here. Okay. C is, again, it's another one that bounces, which is what we said right here. So, all right. And then D, you notice I don't show the vertex there, but what my prediction was is that it would hit it 2 times, and it does here and here. Cat crosses the x-axis. Same thing with E, crosses here at -4 and at -2. F, one time it bounces. This one, because the negative in front of it, it is going to go down, but it's also the vertex. So that helps you. So really, when it says on part H to write a clear explanation describing how you can tell whether the graph of a parabola will touch the x-axis at exactly 1 point, it basically is a quadratic that factors down to the same sets of binomials. So like our part B, it was at x plus 1 squared, okay? Our part C was x plus 3 squared, okay? You see how it's the same, whereas part A and, let's see here, A, D, and E were all different. And the same with F, okay? It was, even though it had a negative, oh my gosh, look at me making a mess here. Let's see here, go like this. Okay. Even though it had a negative out in front of it, it was still x plus 2 squared, okay? So there's not 2 different binomials. There's 2 binomials that are the same. That's probably the best way to say it. That's when it bounces, okay? All right, and if you looked on a graphing calculator on the list for those numbers, like if it was x plus 1 squared, you wouldn't see -1 listed twice. You would only see it listed once because it can't list the same 0 twice. So there's a couple interesting things that you'll probably learn as we go farther, but this gives you an idea of how to look at 2-39. All right, let's move on. Okay, so this is 2-40. And there's a couple things that I want you to realize. Some people get mixed up when there's a negative exponent as opposed to a fractional exponent. So I love that the first one here is a fractional exponent, okay? So it's saying to the 1/3. When it's a fraction, it's talking about a root. So if it's 64 to the 1/3, it is the same as the 3rd root of 64. And if you type that in the calculator, it's just 4, because 4 times 4 times 4 equals 64. Okay. So on the next one, though, where we have a negative exponent, I want that to be positive. So I'm going to start by just distributing that 10. So it's 4 to the negative 2, and then x to the negative 4. Okay. Oops, here we go. And y to the negative 10. I want all of those to be positive just because I'm a positive person. So the way I do that is I move them all down. When there's a negative exponent in their numerator, I move everything down. So it's now 4 squared, x to the 4th, y to the 10th. And I'm just going to do one more step because I can square 4. 16x to the 4th, y to the 10th. And that's part B. On C, I approached this one a little differently. I took care of each set of parentheses first, and I moved the negative exponents down. So on the first one, I would put 2x squared over y to the 3rd, okay? Then on the second one, I left 3 on top and y to the 5th because they're positive, and I moved x down, and x to the 1 is x to the 1, okay? Then what I did is I multiplied all the terms together. So 2 times 3. So remember, it's numerator times numerator, denominator times denominator. So I did 2. Actually, sorry, it's not 2, it's 6. And that's 1. All right. So it's 6x squared y to the 5th on top. And then we have y to the 3rd, x to the 1st on the bottom. Now, when we have, and probably make it easier for you to understand if I switch these, that means I need to get a bigger eraser. Okay, there we go. All right, let's switch those so it makes more sense. X, y to the 3rd. So when we're dividing variables that have the same, that two variables that are the same, and we're dividing them and they have different exponents, we're subtracting. So on top, it's going to be 6, but x squared, it's going to be like x to the 2 minus 1 times y to the 5 minus 3, okay? Because when we're dividing two variables are the same with their exponents, we subtract. If we were multiplying two variables with the same base, we would add. But in this case, we're dividing two that have the same base. So our final answer would be 6x, because 2 to the 2 minus 1 would be 1, and then y squared. And that's your final answer for C. We'll box A and B as well. Okay, that is 2-40. We're moving on to the last one. Okay, so this is kind of a tricky one. So I took a graphic out of the CPM book. Suppose you have a 3 by 3 by 3 cube. It is painted on all 6 faces and then cut apart into 27 pieces, each a 1 by 1 by 1 cube. If one of the cubes is chosen at random, what is the probability that? So the probability, so we'll say probability that 3 sides are painted. This can be tricky, but this visual helps. Okay, we have this side. So there's 1, 2, 3, 4, right? Then 5, 6, 7, and 1 we can't see. So that means it's going to be 8 over 27. Okay, and so let me get rid of, make sure I've got the big eraser, get rid of all of those so we can talk about the next thing. Okay, the next one is the probability. Get back to my pen. The probability 2 sides are painted. Okay. There's more of these, in case you didn't know. Okay, so we're talking about this one, this one, this one, this one. Okay, so that's 4. Then we've got this one, this one, this one, and another one you don't see, so that's 8. Then we have this one, and 2 more you can't see. That's 12 total. So 12 out of 27. And we could reduce fractions on that one, but we're not going to worry about that right now. Okay, so let's get the eraser again so we can get rid of all of these because we're going to do the last 2. All right, part C. Get my pen back. C, probability that 1 side is painted. I don't know why I spelled out number this time and didn't last time, but those are going to be the centers of each side. So just like a dice, we're only going to have 6. So there's 1 on that side, 1 on that side, and 1 on the bottom. So that one is 6 over 27, okay? And so far we have 26 over 27 spoken for. All right, and when I first read this, I thought, wait, what do you mean no sides are painted? Probability, no sides. Because I kept thinking about the surface. But if you think about it, there is one right in the middle that we can't even get to that is not going to have any paint. Because remember, we're cutting this whole thing into 27. So that means there's going to be one right in the center that does not have any painted sides. And that makes sense because this only equals 26 over 27. So it does make sense that that would be 1 over 27. Okay? So that ends lesson 2.1.3's review and preview. If you have any questions, again, go ahead and put them into the comment section of the video. And also give us a thumbs up if you liked the video and subscribe. I would love it if you would subscribe and you can get the rest of the videos. And especially for those of you who are going to be moving on to pre-calculus, eventually I will have pre-calc videos in this curriculum as well. And then I'm going to go back and do Algebra 1 and geometry. So maybe you have a sibling or something that might, benefit from having access to these videos. All right. Have a good one, and we'll see you on the next video. Take care.